In these problems, we're dealing with systems of linear equations and trying to determine if they are what we call dependent or inconsistent systems. So an inconsistent system is where the two lines run parallel to each other. They never cross. There's no solution that could work. A dependent system means the lines are actually two versions of this exact same line. They simplify to the same thing. If that's the case, there's an infinite number of solutions because all of the points are solutions to both lines. One of the ways we can approach this, well, we could put these into slope-intercept form and see if they either have the same slope or if they match completely. We could also just try simplifying and see if they resolve to the same thing. I'm seeing that if I divided the bottom equation by 5, every term by 5, I would get, well, 20 divided by 5, so that would be 4x. 10 divided by 5 would be 2y, and 20 divided by 5 over here would be 4. So this equation simplifies to 4x plus 2y equals 4, which is exactly that equation. So I know, without going any further than that, that this is a dependent system. If that was confusing, you can always just convert these into y equals mx plus b form, that slope-intercept form, and look at them that way. This was just a little bit less work to show they're exactly the same equation. Let's try another. All right. Here, we're supposed to identify the graph of this system and then use that graph to see if it's consistent or inconsistent, and then the number of solutions. So these equations look a little bit annoying. We'll have to do some work to put them in slope-intercept form, but I think we can do that. The first one, we'd have to add 4x to both sides. So we would get negative 3y equals 4x plus 12. Then we'll need to divide by negative 3. And we're going to end up here with y equals negative 4/3 x. Whoops. Y equals negative 4/3 x minus 4. And on this one, let's see, let's add 3 to both sides. So on one side, I'm going to get x plus 3. On the other side, I'm going to get negative 3/4 y. I'll write it backwards from the way it started there, just because I want the y on the left. And this is going to be x plus 3. And then to get rid of this fraction, I can multiply both sides by 4 first. So that's just going to leave a negative 3y over here, a 4x, and a plus 12. And already you can see I'm in that same situation I was there before. Divide by negative 3. I'm going to get the same thing. So I'm going to get y equals negative 4/3 x minus 4. So our equations are the same. They are dependent. That means there are infinitely many solutions. And as I look at the answer choices here, there's only one that gives that dependent infinitely many solutions. And it does seem to have a slope of negative 4/3. It does cross the y-intercept at negative 4. So all of that checks out, and A is our answer.